calculating equilibrium concentrations. This reaction shows that 1 mole of hydrogen gas will react with 1 mole of iodine gas to come to equilibrium as 2 moles of hydrogen iodide gas. We'd like to find the concentrations of all three of these things, both reactants and products, at equilibrium. We have an equilibrium constant given as 64. And we're told we're going to start out with the concentrations of the hydrogen and the iodine being the same as 0.20 molar. For that, we use what's known as an icebox. That allows us to look at the initial given concentrations, the change in concentrations, and the value at equilibrium for each concentration. We know that our equilibrium expression would have the products on top, with its coefficient of 2, remember, 2 hydrogen iodides, and the product of the concentration of the reactants on the bottom. And that relationship set up is the equivalent of 64. The given information from the problem says, well, here's my reaction written at the top, and sometimes they put an R up there for rice for the reaction and call it a rice box. I call it just an ice box. We are told we have 0.20 molar and 0.20 molar, and we don't have any product yet. So what's going to happen is that the reactant's going to disappear. It's going to decrease by some amount x. Both reactants have a coefficient of 1, so they're going to decrease by the same amount, and we're going to have an increase or plus the amount of 2x. Meaning that for every 1 mole of hydrogen that disappears, 2 moles of hydrogen iodide gas appear. So at equilibrium, we'll have 0.2 minus x be the value of our hydrogen gas. 0.2 minus x would be our iodine, and 2 times x, since we started with 0 plus 0, would give us a value of 2x. Returning to our equilibrium expression, we had 2x, and that needed to be squared, and we had 0.2 minus x and 0.2 plus x equals 64. Well, 0.2 minus x times 0.2 minus x, well, that's 0.2 minus x squared. So I can take the square root of both sides, which simplifies as 2x and 0.2 minus x. And the square root of 64 is 8. Solving for x, I want to find the x, which is the concentration of, or the change in concentration is my x value, as 0.16 molar. So let's go back over here. This is 0.2 minus x, 0.16, or my equilibrium concentration is 0.04 molar. Over here, the same thing, 0.04, and 2 times x, or 2 times 0.16, gives me my hydrogen iodide concentration as 0.3 molar. Those are my concentrations at equilibrium.